So we learned about using the moles of one reaction species to find the mole of another, and we could relate a reactant to a product, two reactants or two products that way. Then we learned that we can start with moles and get to grams. I can give you the moles of one of the reactants and ask you how many grams of products may I get. Similarly, I can start with grams of a reactant and ask you how many moles of product I can get. All you have to do is use the molar mass conversion factor to go between grams and mole, and use the coefficient based conversion factor from the balanced equation to go from moles of one reaction species to another. And the most you could be asked is to find the grams of some reaction species based on the grams of something else. Here is an example. Calculate grams of propane required to produce 36.0 grams of water. So we are not looking at moles directly, rather we are looking at grams, and this makes more sense because when you are in the lab and you are carrying out an actual experiment, you would be measuring grams. If you are going to produce water, you are going to be measuring the mass of water and seeing how much water you produce, 36.0 grams of water, for example. And if you are going to need a certain amount of propane, C3H8, to produce 36.0 grams of water, how are you going to obtain it? Are you going to sit down and count the number of moles in propane? No, you are going to have to obtain a certain mass of propane that is equal to the necessary number of moles of propane, which will generate the necessary grams of water. So in a situation where you have to go from grams to grams, you are going to end up with three conversion factors. Since you are required to produce 36 grams of water, the 36 grams of water is your starting point, and let's call it A, my starting point, the amount that I'm given, A, which is 36.0 grams of water, and my B, my destination that I'm trying to reach, is X grams of propane. How will I get there? First, convert the 36.0 grams of water to moles of water. What conversion factor is applicable here? It is the molar mass conversion factor, the molar mass of water. 1 mole of water weighs 18.0 grams of water. And we are not just going to stop right there, we will just link all the conversion factors. The next one, once we get the moles of water in this step, we want to find the moles of propane, and that's what we learned the first thing in this discussion 2 videos ago, how to find the moles of one reagent from another. So what's the relationship between moles of water and moles of propane? In the balanced equation, you will see that for every 1 mole of propane, we produce 4 moles of water. Let's have a look at the balanced equation, and the balanced equation is right here. For every 1 mole of propane, we produce 4 moles of water. So that's the coefficient based conversion factor that we are applying here, and we write it in the form where we cancel out the moles of water from here and here, down here. And if we were to stop here, our answer would be in moles of propane, but that's not where we want to stop. We want our answer in grams of propane. We convert the moles of propane to grams of propane using the molar mass of propane, which you find out on the periodic table. 1 mole of propane weighs 44.0 grams. When you set it up and when you do the math correctly, your answer will be 22.0 grams of propane. So this is as difficult as it gets, where we link 4 conversion factors as you see here. And here is another example. Calculate grams of hydrochloric acid neutralized by 0.500 moles of calcium hydroxide. And here is the equation. Sometimes you are not given the equation. Not only you have to write the equation, you have to balance it correctly as well. Calcium hydroxide is an ionic compound whose formula was given to you, but if it was not given to you, you should be able to derive it. Then HCl is given to you. Because it's a neutralization reaction, an acid-base reaction, the product is salt and water, not table salt necessarily, but any compound made up of a positively charged ion and a negatively charged ion is a salt. So we have in this case our moles of calcium hydroxide, and we are trying to find the grams of hydrochloric acid. First we convert the moles of calcium hydroxide to moles of hydrochloric acid using the coefficients conversion factor, and then we convert our moles of hydrochloric acid to grams of hydrochloric acid here using the molar mass conversion factor. This particular problem only required two conversions, and this is similar to the kind of problems we saw one video ago where we start with moles and get grams. Just be aware that you might be in a situation where we start with grams and be required to find moles. But ultimately, what you see on the bottom part is the most you would be required to go with this kind of calculations here in this general problem solving strategy. We started by learning how to go from moles of one reagent to the other, or then we learned from going from moles of one reagent to grams of that reagent. And the most you would be required is to go from grams of your one of the reagents to the grams of the another. And in each step you are either using the molar mass conversion factor going from grams to moles or moles to grams, or using the balanced equation coefficients based conversion factor going from moles of one to moles of another.